So 4 by p square into p square plus 4 can be written as 1 by p square minus 1 by p square plus 4. Then you have these two terms. So I can simplify it as 1 by p square plus 4 by p square plus 4 plus p by p square plus 4. And now for obtaining y, so y of x will be given by L inverse of 1 by p square plus 4 by p square plus 4 plus p by p square plus 4. Ini L of 1 by p square, okay, L of x is 1 by p square. So L inverse of 1 by p square is going to be x, and L of sine x edukumbo, sine 2x edukumbo, you are going to get 2 by p square plus 4. So this will be 2 sine 2x, and this will be L of cos 2x. L of cos 2x edukumbo, you are getting p by p square plus 4. So L inverse of p by p square plus 4 is equal to cos 2x. So therefore the solution is y of x equal to x plus cos 2x plus 2 sine 2x. So this is how we solve for a differential equation using Laplace transform. So you have an initial value problem with conditions given at 0. Initial conditions are 0 ilana. Okay. So take Laplace transform both sides. So that will give us L of y. Now once you get L of y in terms of p, take the inverse Laplace transform, that will give us the solution y. And now let us look at one more property. So the next property, so this is Laplace transform of derivatives. So to find the Laplace transform y dash, L of y double dash, so on, and hence how to solve a differential equation. Now the next property is called the shifting formula. Now in shifting formula, so shifting formula says that if you have L of e raised to ax into f of x, so this will be equal to L of fp minus a, where f of p is equal to Laplace transform of fx. So if you have Laplace transform of fx to be f of p, then the Laplace transform of e raised to ax into f of x will be equal to f of p minus a. So this is called as the shifting property. So let us look how does this come. So L of e raised to ax, f of x edukumbo, that will be integral 0 to infinity e raised to minus px into e raised to ax f of x dx. So this is equal to integral e raised to minus p. So you can combine these two exponential terms. So p minus a x f of x dx. So this is in the form of integral of Laplace transform, where instead of p you have p minus a. So this will be equal to f of p minus a. So that is the required solution. So this is the shifting formula. So L of e raised to x into f of x will be equal to f of p minus a. So let us look at a few problems using the shifting formula. So find the Laplace transform of so first is x raised to 5 e raised to minus 2x. So L of e raised to minus 2x, x raised to 5 will be, so we have L of x raised to 5 equal to 5 factorial by p raised to 5 plus 1 upper 6 varum. So that will be equal to 120 by e raised to 6. And now L of e raised to minus 2x into f of x will be f of p minus minus 2. So here a is minus 2. So that will be f of p plus 2. So we have f of p equal to 120 by p raised to 6. So you will get 120 by p plus 2 whole raised to 6. So that is the required Laplace transform. Next we have e raised to 3x into cos 2x. So L of e raised to 3x cos 2x will be equal to, so L of cos 2x is equal to p by p square plus 4. So by shifting formula, this will be f of p minus 3. So this is here f of p. So that will give p minus 3 by p minus 3 whole square plus 4. And next you have 1 minus x square into e raised to minus x. So L of 1 minus x square e raised to minus x. So first we need to find what is L of 1 minus x square. So L of 1 will be 1 by p minus 2 by p cube varum. So this will be equal to f of p minus minus 1. So that is f of p plus 1 varum. So replace p by p plus 1. So that is 1 by p plus 1 minus 2 by p plus 1 whole cube. And now let us look at finding the inverse Laplace transform of our shifting formula. Okay. So find the inverse Laplace transform. So first one is 6 by p plus 2 whole square plus 9. So if you take L inverse of 6 by, അപ്പോൾ ഇവിടെ p യുടെ പ്ലേസ് p plus 2 ആണ്, അതായത് e raised to minus 2x വെച്ച് മൾട്ടിപ്ലൈ ചെയ്യുമ്പോഴാണ് p plus 2 വരിക. Okay. Now let us find what is L inverse of p square plus 9. So this is L inverse of, so I can take 2 outside of 3 by p square plus 9 will be 3 square. Okay. So this will be for sin 3x. So L inverse of 6 by p square plus 9 will be 2 sin 3x. So therefore L inverse of 6 by L inverse of 6 by p square plus 9 is equal to 2 sin 3x. So therefore L inverse of 6 by p plus 2 whole square plus 9 will be equal to e raised to minus 2x into 2 sin 3x. So that is the required transform. Now next you need to find L inverse of 12 by p plus 3 whole raised to 4. അപ്പം p plus 3 വരുന്നതുകൊണ്ട് e raised to minus 3x ആണ് വരുന്നത്. So let us first find L inverse of 12 by p raised to 4. അപ്പം p raised to 4 വരണമെങ്കിൽ നമുക്ക് x ക്യൂബിന്റെ ആയിരിക്കും വരുന്നത്. So L of x cube will be 3 factorial by p raised to 4 varum. So this is 2 L inverse of 6 by p raised to 4. That is 2 L inverse of 3 factorial by p raised to 4. So that is 2 x cube. So L inverse of 12 by p plus 3 whole raised to 4 will be equal to 2 e raised to minus 3x into x cube. So that is the required Laplace transform. Next you have L inverse of p plus 3 by p square plus 2p plus 5. Okay. Here p plus 3 by p square plus 2p plus 5. So you can write it as p plus 3 by. So let us complete the square in the denominator. Then we p plus 1 whole square plus 4 എന്ന് എഴുതാം. So that is അപ്പോൾ നമ്മുടെ ഡിനോമിനേറ്ററെ നമുക്ക് p plus 1 whole square by 4 വരണമെങ്കിൽ അത് സൈനോ കോസോ വരുന്നതായിരിക്കും. So let us split the numerator into two terms. So you can write it as p plus 1 by p plus 1 whole square plus 4. So it is in the form p by p square plus a square. Then you will get 2 p plus 1 whole square plus 4. So it is in the form a by p square plus a square. Ini p plus 1 ആണ്, അതുകൊണ്ട് e raised to minus x ആയിരിക്കും multiply ചെയ്യുന്നത്. So L inverse of p by p square plus 4 plus 2 by p square plus 4 will be equal to cos 2x plus sin 2x. Now multiply e raised to minus x with that. So that gives the required solution. So therefore L inverse of p square by p plus 3 by p square plus 2p plus 5 will be equal to, so you will get e raised to minus x cos x plus sin x. So that is the required solution. So it is not cos 2x and sin 2x. Sorry. Okay. So it is cos 2x and sin 2x. So that is e raised to minus x cos 2x plus sin 2x. So that is the required inverse Laplace transform.